Good evening, everyone. Yeah, here we are again, and we are going to try in this video. We're still taking you through the same model that we are coming up with, and we are going to show you the web version of it that we have tried to put in place. Well, in this case, we are using a Streamlit interface for interfacing with a machine learning model. So that we can visualize the training statistics and maybe query the similar questions via FACE and all that. And in this case, we are focusing on about faucets. Yeah, we are looking at viewing the training statistics. For example, where they are reading the values from a log file and then they can display them on the app and also show us how the training performance is moving on and all that. And then we're also looking at a part where you can input your question and solve the math problem so that it can give you back feedback. Yeah. And then we're also looking at a set where you can query similar questions. Like you put in the question and it brings for you like, okay, according to what I have, these ones are closely related to it. Yeah. And we're also looking at part of visualizing the model performance through the different visualizations that we have. For example, the loss curve, the confusion matrices, and all that. So this is basically the interface of it. We have a navigation bar that has a part where you can choose an option. And when you select an option, it takes you to the option you select. So if I select the training stats, it's going to bring for me this. This is the loss curve that it's going to bring for me. I hope you can see it. Yeah. Then there is a gradient norm, which is this. Then we have a training accuracy, which is this. We have a learning rate, which is that. We have a loss comparison, which is here, where we compare the loss thingies. Then we have a token distribution. We have a predictions versus ground truth. We also have the TSN for embeddings, the feature importance, the phase query, and the part for solving the math problem. Yeah. Sorry, the internet is taking a bit long to load. Yeah, but this is the part for solving the math problem where you input your question and have it solved. Yeah, and all this comes from this part of this code that is written. It's hosted on GitHub. So it's in a file of app.py. And every part that you're going to actually look at in this code that has st dot something, that's the part that actually acts as more of the front end of this. So for example, the part that has st dot sidebar dot header navigation bar. When we come back the other side, it's where we are going to find that there is a navigation bar that is written on header and all that. So this other part that comes in is more of a bit of the back end of it, of how it's actually going to work. Yeah, so that's how the front end actually looks like. And this is the code that works on all that, the tokenization distribution, where it works on that and then outputs it the other side. Okay, so my government is going to take you through the other part that we have to give to you in this video. Yeah, thank you.
Hello, everyone. As I said, I'm going to take you through the code representation of the model, how it was run, and how we were able to represent it in an interface, and also how to deploy it. So we can see that we have a file here called load.py. Now this file contains the code where we are able to tokenize our data and pre-process it, create an extra data set from it with encodings, and able to pass it through our model. So due to our device model specifications, we weren't able to get a very large model and one small model, which we called NEO model of 125 million parameters, which we are able to run. And then from there, we're able to tokenize our data based on the data set, which is in the form of a JSON line file data type. So we first change it into a data frame, and we're able to create a clean question in a JSON line file. Then from there, we're able to also load the tokenizer and be able to tokenize the data based on that tokenizer with a part of a max length and a max length of 128. Then from here, we're able to also initialize our device. So if we're using a GPU, we have CUDA. And for my case, I was using CPU, so we have to specify CPU. Then it's going to load it on the device, and it will load the model there. Then the main part here is this part called training args. So training args here, we're able to specify the number of epochs we want to train, the evaluation strategy or the learning rate, the total limit for saving, and the output directly for our model. Then from there, we run our trainer, and it's going to evaluate those results and save the model elsewhere. So from here, when it comes to deploying, we're able to use a platform called Streamlit, which gives us an interface in which to run our models. So for example, if you're doing machine learning or even some graphical work, you can use Streamlit to deploy. So basically, I created an account there, and I was able to open an app or create a private app there where I can configure or modify the settings. So the Streamlit app looks like this. As you can see, we have the training stats, which my group mate already took you through. And as you can see here, we have what we call we're able to pass all these values and visualize them here via Streamlit and here, or maybe the gradient normal or the training accuracy here. So all this, the deployment is done in this file called app.py, which gives us the ability to get the data from the model we already trained and now load it and maybe get statistics from it, get the phase index, or maybe evaluate the predictions from it. So from here we can see they give us saved it in GitHub in our repository. So you first have to load it from GitHub. So I signed up using GitHub, and I was able to pick out the repository and use it for and it gives us the ability to configure it, change it either to bro. I'm sharing. So from here, we are given a dashboard where we can edit, see the analytics of the app, see the viewers, see whoever is able to view our thing. Then we can change its settings either to make it public or private. And then from here, our dashboard, we are able to run various graphs and tables, as you can see here, this loss curve. So as you can see here, we're able to visualize the loss curve from here. And visualizing it, we are using matplotlib together with pandas to data for the data frame. Then we're able to also handle the phase query. Now the phase query, which is the Facebook AI simulation search index, where we're able to put a math problem. For example, you can say, give me the product of 5 and 17. And from here, we're able to, so what the phase index helps us to do, we are able to get the similar questions, the top 3 similar questions and their similarities. So since this is a product, we are able to see the question, the topmost question, which has a similarity of negative 0.05. So it's almost close to its similarity. And then the next one has similarity of 0.07 and next one 0.10. Then, so all this is scattered here in the code where we have a function called loading training stats, where from this thing, we're able to get the trainer state.json file. We're able to get the log history, the accuracies that were able to be collected via a checkpoint. And then we're able to run the model which we obtained. The model, we're able to run this model, as you can see, math.pt. So from this model, we're able to run the actual model and use it to generate all these statistics. Then here, as my group mate already talked about, the interface, which gives us a sidebar and the header and also other various features. Yes, thank you for listening.